Hello and welcome to my ME5250 Project 2 video demonstrating my simulation. Before I show the simulation, I just wanted to give some background and behind how the simulation is, what we're setting up, and just some of the basics. So the first figure is showing the initial position of the 3R pendulum. This 3R pendulum consists of 3 links and 3 revolute joints. So the 3 links are of length L1, L2, L3, and at the end of each length is a concentrated mass of values M1, M2, M3. So when looking at the forward kinematics as seen in figure 2 of this triple pendulum, the way we usually describe the joint angles are as such, with theta 1, theta 2, theta 3, with theta 1 being the angle between the x-axis and the first length, theta 2 being the angle between the first length and the second length, and theta 3 being the angle between the second length and the third length. How I've done it to simplify the math for later on is I've defined theta A, theta B, and theta B. Theta A, theta B, and theta C being the angles from the x-axis to links 1, link 2, and link 3 respectively. So in terms of theta 1, theta 2, and theta 3, theta A is equal to theta 1, theta B is theta 1 plus theta 2, and theta C is theta 1 plus theta 2 plus theta 3. So now if we want to simulate the motion in Python of the triple pendulum, we can run this code, and this is the triple pendulum initially acting under only gravity. Beginning, it is smooth motion as we just predict, as it swings back and forth, but over time it starts to become chaotic motion, as we can see here. This is for the case where they are unit link lengths and unit masses. So the swing arounds become more and more chaotic and more unpredictable, not being able to tell where the pendulum is going to end up being. So that's very cool, and the simulation starts from the beginning. We can also, in the code, change the case, so instead of it being for unit lengths, we instead look at the case for when we can change the masses and the lengths. So let's look at the case where we make the final mass, mass 3, to be 3 times as big as the first 2 masses, and we make the second 2 link lengths to be twice as long as the first link length, and we can still simulate and see the chaotic motion. So here's the new simulation. So we can see already that it's different from the initial unit length, unit mass pendulum. And we get this chaotic motion. Again, keeping in mind that the third mass is heavier, 3 times as heavy as the middle 2 masses. It's quite interesting. See it do its thing. This part's pretty cool. And then it starts from the beginning. So that is all for my demonstration of my triple pendulum. Thank you.